Alright, today all we really do is add two pieces of vocab, angles of depression and angles of elevation. But the way we work the problems is exactly the way we've been doing them with sine, cosine, and tan. It's just now we're going to be doing word problems where you have to draw and come up with your own triangles. Okay, so the first one over here. The angle between a horizontal line, and that's important, it's got to be a horizontal line, and the line of sight to a point above the observer is called the angle of elevation. So my picture over here, there's my little dude standing right here, and he's looking up at something above him. Here's his line of sight. There is the horizontal. This is the angle of elevation. Okay? Angle between a horizontal line and the line of sight to a point below the observer is the angle of depression. So there's my guy. He's on top of a mountain or a cliff, whatever. Here is the horizontal where he is straight ahead. This is his line of sight. So the angle of depression is between the horizontal line and the line of sight. A lot of you guys want to mix these up and say that this is the angle of depression, this angle right here. This one is not the angle of depression. It is this one because it is made with the horizontal and the line of sight. Again, we'll do more practice in class. Just look real quick. Look at these two angles. Can you guess what might be true about an angle of depression and an angle of elevation just by looking at this picture? What kind of angles are they? Do they look familiar to you? Well, they should. And we answer that question right here. The angle of elevation and depression for the same setup are always what? They are always congruent to each other. And why would that be? Let's go back to the picture. Again, if you've forgotten some first semester stuff, what kind of angles are those? Those are alternate interior angles. And these lines are parallel, they're both horizontal. So because they're alternate interior angles and my lines are parallel, my angles of depression and angles of elevation for the same picture, for the same setup, are always going to be equal to each other. And we're going to use that here in a little bit. Okay, let's just identify angles of elevation and angles of depression. So here's my little picture. Somebody's standing down right here and they're looking up towards this flagpole at a 50-degree angle. So what kind of angle is that? Is that an angle of depression or an angle of elevation? That would be an angle of elevation because they're looking up and one of the sides is horizontal. It must be made with a horizontal line. All right. This one, flying an airplane. They're looking down at a 52-degree angle. Again, they're up above, they're looking down. We're using this angle, which is made with the horizontal line. That must be an angle of depression. All right, what about the last one? So we got somebody maybe standing on top of this cliff or this mountain, and they're looking down. This is a 55-degree angle. Is that an angle of elevation or an angle of depression? What are we thinking? Okay, it's neither. It is neither an angle of elevation or depression. Why? Remember, an angle of depression and an angle of elevation must be made with the horizontal line. So the two lines that make up this 55-degree angle, neither one of them is horizontal. This one is not horizontal and this one is not horizontal. So this is neither an angle of elevation nor is it an angle of depression. One of the lines must be horizontal. All right, let's do some problems. You'll see why I went into math and not art. So that is my picture. There's my building. It says I've got a building 25 meters above the ground. So this line right here, this vertical line going up and down, that's my building. So it's 25 meters above the ground. It says someone is standing up there and they're looking down at an angle of depression of 27 degrees at a car. And so here's my car, this little dot over here. So my building is going straight up and down and here's my car. And then I made a horizontal. Remember, angles of depression must be made with the horizontal. So if my guy's standing up here, there's my horizontal line. This 27 degrees right here, that is my angle of depression. But then we remember, well, angles of depression and angles of elevation must be the same. So if that's 27 degrees, then that must be 27 degrees. And what I'm trying to find is this x, how far the car is away from the building. So now I've got a little triangle, that's 27 degrees. I know this side and I want this side. So what trig function is that going to be? When I know the opposite and I want the adjacent. That's just going to be tan. So my equation is tan 27 equals the opposite side, which was 25, over the adjacent side, which was x. Multiply both sides by x, and I get x tan 27 is equal to 25. Then divide both sides by 27, and I get x equals 25 divided by tan 27. At that point, I got the x by itself, so I go to my calculator, and I put in 25 divided by tan 27, and I get the x has to be 49 meters. So the car is 49 meters away from the building. All right, I like this problem. Again, you'll see why I didn't go into art. So I've got a fire truck that is 6 feet tall. Got a fire truck 6 feet tall. I've got a ladder that can reach to that can extend to 120 feet, and it's sitting on top of the fire truck. So the ladder is on top of the fire truck, and it's resting against the building, and the biggest angle that it can make is 75 degrees. So the longest that we can make the ladder is 120 feet. We know it's on a fire truck 6 feet tall, and we know the angle's got to be 75 degrees, and we want to know how far up the building can that ladder reach. Okay, so here's my beautiful picture. So there's my truck, that rectangle. That's my fire truck. Well, we know it's 6 feet tall, so we know from here to here is 6 feet. There's my ladder extending from the truck and resting against the building. We know that's got to be 120, and we know the angle that it makes is 75 degrees. And I'm trying to figure out this piece over here, this piece of the triangle. Again, this is the angle that I know. This is the side that I want. This is the side that I know. In relation to this angle, this is the opposite side. This is the hypotenuse. So which trig function would I use that uses opposite and hypotenuse? Well, that's going to be sine. So I take the sine of 75 degrees, that equals the opposite side, which was x, over the hypotenuse, which is 120. Multiply both sides by 120 to get the x by itself, so I get 120 sine 75 is equal to x. I've got the x by itself now, so I go to my calculator to put it all in, and I get that x is equal to 115.9. Okay, so am I done? Have I answered the question? I got x. Am I done? Did I sufficiently answer the question? Again, the question was how far up the building will the ladder reach? Well, I only know how far it is from this point to this point. But I also need to factor in this little piece right here. Well, that's 6 feet. I already know from here to here 6 is that's the height of the fire truck. So all I have to do is take that 115.9 that I found and add 6. So the total height it'll reach up the building is 121.9 feet. Okay, this next one, I really wish we hadn't have gotten this one yet. This is a pretty good problem. I would have liked to have done some easier problems first, but it is a good problem, and it's worded kind of funny if you read that first sentence. A pilot flying at an altitude of 2.7 kilometers sights 2 control towers directly in from of her. I don't even know what that means. Okay, so here's my airplane. That dot is 2 point, and I added a 5 there too. I have no idea why. I put 2.75. I don't know why I did that instead of just saying 2.7. So this airplane is 2.7, or in my case, 2.75 kilometers above the ground. He sees 2 control towers. So there's one control tower, there's another control tower. His angle of depression to one of the control towers is 58 degrees, and his angle of depression to the other control tower is 37 degrees. And all they want to know is how far apart are these 2 control towers. Okay, I'm going to mess with the 58 degree angle of depression first, and that involves the solid line right here. So for now, just ignore that dashed line. So my angle of depression to this control tower is 58 degrees. So I then drew in the solid line, which makes this angle 58 degrees. Now, I want to know how far this distance is from these 2 pieces right here. How far is this control tower away from this piece? So again, which function is that? When I have this angle, 58, I have this side, and I want this length right here. That's going to be tan. So that's what I did. So I did tan 58 equals 2.75, the opposite side, over the adjacent side, which was x. Multiplied both sides by x, and I got x tan 58 equals 2.75. Divide both sides by tan, I get x equals 2.75 divided by tan 58, so x equals 1.7 kilometers. So from this place right here where my right angle is to this control tower, it is 1.7 kilometers. Okay, I know that. Now, let me use my dashed line and my 37-degree angle of depression. So now I'm going to ignore this solid line. So my angle of depression to this control tower is 37 degrees. Which means, again, my angle of elevation over here must also be 37 degrees. So now I'm going to do what I did a while ago, and now I'm going to figure out this whole piece, how far it is from this right angle to this control tower, which again is going to be tan. It'll be tan 37 equals 2.75 over the adjacent piece. So that's what I did. And I got tan 37 equals 2.75 over y. I just called it y this time. So y is the whole thing. Multiply both sides by y tan 37 equals 2.75. Divide both sides by tan 37. Y is equal to 2.75 over tan 37. So then y is equal to 3.6. Okay? So it's 3.6 all the way from this spot to this control tower. 3.6. And we just figured out that it was 1.7 from this right angle to this control tower. So then what does this little gap need to be? If it's 1.7 from here to here and 3.6 from here to here, what does this piece need to be to add to 1.7 to get 3.6? Well, we're just going to subtract 3.6 that we got for this distance. We're going to subtract 1.7 and we're going to get 1.9 kilometers. Again, this is a complicated question. If this is the only thing that's bothering you right now, you're right where you need to be.